work for a firm called Jump Trading. If you have any interest in trading firms or high-frequency trading, please feel free to grab me and talk about that whenever you get a chance. Today I'm here to talk to you about primarily delivering REST APIs using a bunch of tools. So a little bit of history. I've been doing web dev for about 20 years now. So I remember back in the good old days when it was, static HTML files on disk, and then there were these funny CGI scripts, which we've once again decided is a good idea with serverless, right? If anyone's been on both ends of that. My first big Python project was building stuff with a thing called Zope. Have we got any Zope people here? One. Good. Anyone else? Clone? Okay, cool. That's also a good sign. The world moved on. We've had Django come along. Django's then grown the Django REST Framework, which has ended up where I spend a lot of my time is building REST APIs using DRF, and a colleague of mine will build a React front end using wonderful React things I don't understand. So I've got to a point with Django where I want to try and find out what's coming next. So I've been with Zope, I've seen Django come along, it's like, here's a bunch of stuff in Zope that we could probably do differently. Let's see how we can do that. And I think we're now in a position with Django where it's like, okay, we've seen how Django's done the world and all the differences it's made. What can we also do now that's like the new things we've learned in the 10, 15 years since Django first rocked up? So the technologies I care about, I'm going to cover in this talk, are REST, which is the way you form your API, Async, which is one of the ways you can deliver it, and dependency injection, which is a thing that, thankfully, there was a talk about this afternoon. Who was in the DI talk? It's going to make my life so much easier. So I think DI is a really good idea, and I think it works particularly well when helping to deliver web frameworks. So to get into a bit of what these things mean, REST APIs tend to have an HTTP verb, a URL which relates to a piece of data, and some parameters associated with that. So you generally end up with kind of like a thing which returns a list of objects, a thing which returns a specific object, a thing which lets you create objects, and things that let you update and then delete them. So async. Who here's been to lots of async Python talks? Because then I can skip some of this stuff. I'm hoping everyone's like, lots of async people. Oh, okay, it's not that many, right? So normal Python stuff is like, here's some code. Can you please do what I ask you to do? And you'll go from line to line, and stuff will happen in order, and nothing unexpected will happen. Async is saying, okay, can you go and do some stuff? But that thing I think we're going to go and do there is going to take a while. It's normally going to involve a network thing or some disk or something like that. It's going to have an answer, but at some point in the future. In the meantime, I'd like to do some other stuff. So tell you what, can you pretend you've called it and then give me something that looks like an answer? So this awaits bit here is basically saying, look, go off and do this stuff. Give me something that looks like a response, and when it's ready, I'll be able to do something with it. So that's the breakpoint there. I'm not a fan of async for application developers. As someone who writes a lot of applications, async puts the onus on you to decide when the rest of your computer should be able to do stuff. It's extraordinarily easy to get wrong. It means that you can very easily write code or block your whole web application rather than just make one request slow. As a result, I don't think it's great for application developers. It excels at the fact that it is the most efficient way of dealing with thousands and thousands of network sockets. So my take on this is kind of like, well, your framework should handle this stuff and present you a nice synchronous interface. But, before I move on quickly, the sort of cutting edge of Python web development seems to be very heavily focused on asynchronous callback syntax and lots of awaits everywhere. So dependency injection is great, because now I can skip through this bit a little bit more quickly. The idea here is that rather than saying, like, I need to tell you exactly what you need to do, you set up your functions to say, these are the things I need to do the stuff that I want to do, and I'm going to give you back something else. So just quickly on this one, with the type annotations we have in Python 3, this is saying, okay, I want to set a database session, I need a string for a name, and I didn't put the, with the return syntax, saying I'm going to give you a blob of JSON which I'd like you to return to a web browser. So, with those things in mind, I looked at what are the current web frameworks I would pick. So I could stick with Django DRF. It's very productive. It works well for me. I've built some fantastic applications with it. It doesn't excite me. It doesn't fill my world with joy. So what are the other options? Flask is something that's there. But I think, just remember, I've got some slides for these. So stuff to like about Django, and DRF in particular, is getting this free UI down the bottom of this. This UI that's like, okay, I can actually interact with my REST API without having done any front-end development. But I have all this baggage of kind of like, it's Django stuff with a settings.py and an RM which I absolutely dislike a lot. So what are the alternatives? Flask is there. Flask is, I know, another very popular framework which I've never looked at because for me the abstractions are wrong, right? The fact that you import a session and a request object and those suddenly become magically scoped to your request handler is just, for me, fundamentally doesn't fit my brain. And no, it's a very productive framework for a lot of people, but it doesn't work for me. On the other hand, Pyramid is probably the most flexible and well-architected framework I've encountered. It's an exceptionally graceful piece of software. If you want to go and see a really great Pyramid code base, if you go and look at PyPy's code base, so the package index, it's a Pyramid app, it's really nicely done. Why not go that way then? There's no kind of DRF equivalent in Pyramid, and it's all synchronous, it doesn't do any new, the new fantastic async stuff that everyone thinks is a really good idea. It also has a really, really small community, which I struggle with sometimes when I look at like, what's the tool I can recommend to my colleagues. If there are 20 people that I can speak to about that, it's like, okay, they may struggle to get help when they need it. What can we do instead? Another framework that I bumped into is a wonderful one called Hug, and this is the first Python web framework I saw like, oh, actually this does dependency injection in a really interesting way. So with Hug, as you can see out there, from my request handler, I say, well, these are the things I need. I want a name, I want an age, and I want like a timer. Can you please get them from somewhere? So it looks great, there's some really interesting ideas, but just when I looked into it, the main maintainer kind of just went absent for about 3 or 4 months, and I found that was really scary because it's like if you're putting your business on the line for this, and suddenly the main person who can do things is just not there anymore, it's a bit concerning. It also has this notion of not just targeting REST APIs or web APIs. You'll see there's like the .local thing there is like, all right, can you give me a CLI that works like this as well? Which is a nice idea in theory, I just think it becomes a bit too difficult to do in a generic fashion. So I ended up coming to FastAPI and like found this thing. The change from that is Tom, who wrote DRF, went off and did this thing called API style, which is like, okay, I've done DRF now I want to write something from scratch and do everything great. API style was kind of like a prototype of a thing that was purely designed to develop, deliver REST APIs. He kind of pivoted on that to working on Startup, which is just a pure async web server in Python for doing just very simple async stuff. And a guy called Sebastian built this thing called FastAPI on top of that, which is like, okay, this is really interesting. So what's the stuff he's added? Well, it's a nice clean system of URL mapping. It's entirely dependency injection driven. And it has the same nice UI built from your APIs that we'll see in a second, as well as having a really active, small but really active community. So there's it's a Git or one of these newfangled web things that you talk to people on. Discord, maybe one of them. But there might only be 20 people on there, but they're already really all active and engaged. It's not just 20 people use it and everyone answers questions. These are 20 people I can go and ask things 24 hours a day. Because it's also built on Startup, which is this underlying async web server, you do get a lot of future-proofing stuff for free. So there's WebSocket support, there's GraphQL support. It's not front and center with FastAPI, which is okay with me because I don't need those things specifically, but it's nice to know that they're there if I do need them. So that's my reason behind it. Now I want to kind of crash into like, okay, so I've decided to use FastAPI, how do I do stuff? First thing you always need to do in your web app, map some URLs. So in this case, you can see you instantiate your FastAPI object and you just wire in an HTTP method to a particular URL. You can have subrouters, so you can say, okay, I want to cluster these URL handlers together. They might ship in a separate package, so if you've got like something you're sharing from someone else, you can say, I can wrap these up together. Getting stuff from requests. Okay, so we'll need to get various things from requests. How do you do that? So if you've got a segment of your URL which you want to pick out, so like an ID in this case for an event, we can use either just say like, I need an integer ID, you haven't given anywhere else to come from, so it'll pick it up from the declaration you've made in the top of the URL. The more explicit way at the bottom is actually saying, look, and this is where the dependency injection stuff comes in, I actually want this explicit from the path and it must be provided. Next bit, okay, URL parameters. Again, if there's nowhere else they can come from, you can just declare them with a type and they'll be extracted from the URL for you. Nice, clean, small bit of code, really, I mean, for me anyway, really obvious as to what that does. Again, down the bottom, much more explicitly saying these have to be query parameters. There's a default, there's some other bits and pieces I've said, like the string that I'm going to look for must be less than 20 characters long. Slightly more esoteric things that people might not necessarily bump into. Getting a header. Again, we're starting to see a pattern here. It looks really similar, right? Okay, where do I want it from? Well, I need a header. I need it to be called authorization. And if it's not there, just give me a null instead. What about cookies? Again, same pattern. Here's a cookie. If it's not there, just give me a none. If you're wondering what that thing is next to it, that's actually the Unicode cookie character. Because I thought, how do I indicate this is a cookie? And it's like, turns out there is actually a Unicode glyph for cookie. So, and how it renders, I have no control over. So apologies if it doesn't look like your cookie. Again, less popular nowadays in the grand scheme of like JSON delivered REST endpoints and all these kind of good things. If you need to get stuff from a file, from a form submission, so this is normally file attachments and the like, you can say it comes from a form or it is a file. Again, same pattern as we've seen now consistently. The type declarations tell you what it is, and the default values, or that's the dependency injection saying where does it come from. So that brings us to like, okay, what's the core of a REST API? Now for me and most people who use them, it's the data exchange format is JSON, right? So you're getting blobs of JSON from it, and you're sending blobs of JSON into it. So we've got an incoming request. The body is this lump of JSON that we see here. What do we do with it? Okay, sidestep a little bit. How do you verify the format of some information? So you have some kind of serialization, deserialization thing, and you also need to say like, okay, is this valid data? FastAPI leans heavily on another library called Pydantic for this, which is, we've got a little example here. So we've got a Python 3 enum. We have a small event object which has got a date, a type, and some text associated with it. That subclass is Pydantic's base model, and then we can say, okay, this is now a really simple way, at this level, it has nothing to do with REST frameworks or anything else, but it's a really simple way of saying, okay, is data valid? To show that in use, so we've got our model up at the top. If it's a valid one, we just get this object back, which happens to match all our data. If it isn't, we get some helpful error messages, which I think they're down there, and they're a little bit smaller than I would like. But it's kind of like it says, hey, this date format was invalid. This field was required, but you didn't specify it. That exception presents itself in a way that a web framework like FastAPI can unpack and show you a useful error message back when you get it. So, how do we say we want our blob of JSON that came in on our request, and we want to turn it into an object we can use in our application? Again, same pattern as we saw before. We say we need an event, and we say it's required. That event is the Pydantic model we saw before. So that one up there. And FastAPI knows to look at this and says, all right, okay, so someone's asked me for an object. There's only one place an actual object can come from that they haven't been very specific about. That must be a blob of JSON in the body. So you get this really lovely succinct syntax that says, okay, where does my stuff come from? So we've kind of sucked all our data out of the request stuff. See, HTTP is nice and simple. It means that my poor little brain can actually get my head around it. Something comes in, I do some stuff with it, something goes out. So how does the framework let us put stuff back in the response? Simple enough. If you're just returning some data in the body, you can just return simple Python objects, right? So in this case, a dictionary of strings, that's going to get rendered to JSON by the framework and returned to the browser to do whatever you want with it. Okay, but we have this nice validation thing, and we might have some objects coming back from a database, whatever, then what do we do with them? Same thing, FastAPI leans on Pydantic to say, okay, here's what I need to return to the browser. So you see the response model stuff up there. I want to return an event, and actually, while you're at it, please can you make sure that this endpoint always returns a 201. Now that's slightly, you might say, okay, but that feels a little bit weird. So this is a post endpoint, which is either going to successfully create an object, or you're going to get an error. So if an error happens, it's an exception, and the sort of exception handling machinery is going to catch that and turn that into a sensible status, sensible HTTP response with a nice status. So if that doesn't happen, then it's nice to just say, okay, like everything that comes out of here is a 201. I don't have to muddy my code up with figuring out HTTP responses. And I can just return a data dictionary at the bottom, nice simple Python data type, wherever that's come from. We'll come back to that in a bit, but there is also good support for RMs, so you don't necessarily have to deserialize everything. How do you set headers? So in this case, two ways of looking at it. The nice DI way, which is saying, okay, I need to do stuff with a response. Well, I need a response, so I declare that I need a response. I get hold of the response, and then I use that object that I've given to set some headers on it. if you're more used to frameworks that say, actually, I want to form a response object myself and be explicit about that and return it, then you import directly from Starlet and say, look, I want to return a JSON response here. Part of that response is these headers, and then there's the content as well. Keeping up with stuff that, again, hopefully libraries will take care of most of the stuff for the things you need to use it for. But if you want to set a cookie, you can, again, either do it on the response explicitly or return a JSON response object where you set your cookies. Right, so what's all this given us? So we've done a lot of declaration up there. There's like been a lot of text that we've typed. And if you're like me and think these type hint things that come in Python 3 are new and weird and they haven't done them for the last 20 years, so why do I need to do them now? What's the benefit you get from that? What you see here is an open API web front end that will come from your FastAPI application for free. I've not done anything to code this up. All I've done is hit the /docs URL on my API, and I have a nice interactive, you can actually use these forms to submit data, test things out. I'm told by the front-end developer I work with, the front-end devs really love this because they can play with your API and use it before they build what they need to on top of it. So, I mentioned before that I'm not a massive fan of async programming. And one of the things I really like about FastAPI is that you're not forced to write your URL handlers as asynchronous code. If you write a synchronous function, it will be handled correctly by FastAPI. As it happens with all these things, it will get fed off into a thread pool, and it will get executed there, and it doesn't matter that it blocks. So, the difference in FastAPI between writing synchronous and asynchronous request handlers is whether you put the keyword in front of your def statement. So if you have something that's a coroutine, it will be treated asynchronously and will be handled correctly. If, like me, actually I just want to write simple Python code that executes in a line and I don't have to think too hard, then I can just write a synchronous function. So with the earlier DI talk, you guys are a bit ahead of the game on what I was going to say here. So we've seen it a lot in the kind of like, how do I get stuff from a request? Well, if I declare stuff saying this is a dependency, my piece of code needs to do that, I will get fed it by the framework. Now, what's quite interesting is you'll see some ones down here that are a bit different. So I've got a DB session, which is just something that I can call, and I've said I depend on that. So the framework then knows to actually go and call my function, keep the result. As it turns out nowadays, it then caches that result for the request. So if you have lots of functions that call these things, and feed me that dependency when I've asked for it. Same goes for get current user. So it's like, okay, I need to have a user because I need someone to be logged in to see this request, so call this function and it gets a chance to do stuff. The difference between depends and security is not a lot. There's actually a bit of the only difference is actually one I won't have time to show you today, which is to be able to say which OAuth 2 scopes you need. That's the only difference the security one makes. So okay, this is nice and simple, and it's great because it's simple to think about on one level. What's most interesting is if that get current user method or function now has dependencies on other functions. This is, FastAPI knows recursively to go and look for dependencies where you set them and give them to you as you need them. So as you're building up your web app, you get to write simple, small functions which say what they need, and they compose themselves together by way of declaring the dependencies. For me, this gives you a much simpler way to think about stuff because you only ever have to think about one small function. You can only have to test one small function in a go, and we'll come on to testing later on. So to try and work through a bit of this, I wanted to have like a little sample application to work with. And for me, I am basically a stream processing device. So I have a to-do list, and then I do things, and then I write them down in a journal so I can remember I've done them. It's also helpful for things like if you end up dealing with utility companies that tell you, no, you never told us that. It's like, well, actually, I wrote down that I told you that at like 4 p.m.-ish about 2 weeks ago. And as soon as you can provide them with a record with it, they tend to be much more interested about listening to you. So I want a simple system just to be able to store this stuff in a database. My ORM of preference is SQL Alchemy. One of my kind of prerequisites for finding a framework is one that works nicely with SQL Alchemy. So for this app, we just have a simple model. So we've got our model down there. We have our enumeration again, and I want to use that. So I need some configuration. This is using a library that I've mentioned to some of you guys now called Configurator. I haven't got time to go into it, but have a Google for it, Configurator Python README. It lets you layer up your configuration sources. So in this case, again, I'm using a pedantic schema to set what my configuration looks like because it's the tool that's there. My configuration is very simple. I have a database and I have whether or not I'm testing. And the database is just a URL. So I need to load that configuration up. Well, I write a function that loads that configuration up. It might come from a path. If I haven't specified a path, it just figures it out and says, okay, I'll get it from something called app.yaml in roughly the same directory as this code came from. And I'll go through and validate it and return the config. So this is what I mean by dependency injection. It's a simple thing that I can reason about on its own. Okay, now how do I wire that into FastAPI? So it turns out this is actually, I think this is actually provided by Starlet, even though it says it's FastAPI that you're doing it to here, but you can wire things up to events. In this case, I'm getting startup. I want to load my configuration and configure my database session. Okay, now this bit's a little bit clunky because that DB session stuff that we saw before, where does that actually come from? Well, actually, it turns out all that's really doing is getting it off attribute on the request. How am I actually making sure that happens? So we see our request handler at the top there. This is using another little bit of Starlet to say, look, okay, actually I need to have a bit of middleware, which in this case is asynchronous and calls it, so we're effectively context managing our database connection. Here's a connection we're running in. I'm going to skip on because I'm running out of time, which I was worried about. But so these are the schemas for applications. So these are the pedantic schemas. So we've got different types there. A list of events. Difference between event full and event non-primary key. If you're creating an event, you don't have a primary key for it yet, so it doesn't have a database identity. The full one, of course, does. So creating stuff. This is a function there. We can see we've got our database session. We create our object from the stuff that's coming from the request, add it to the session. Simplify is basically just a function I haven't shown here, which takes your object and turns it back into a simple dictionary. The SQL Alchemy objects have a bunch of attributes. And I wrote this before FastAPI now natively understands SQL Alchemy objects. You don't have to do this anymore, but it's still there. Reading them, even more simply. So we widen our URL handler. We have an ID. We'd say we need a database session. From the session, we look it up. If it's not there, we return a 404 by raising an exception. If it is there, we just return the object. Listing ones, I haven't gone into the full detail of this because it turns out a lot of the tediousness with listing objects is actually pagination. So in a REST API, it's not really safe to try and return many thousands of results in one request, so you tend to page them out. The paging code is tedious in there, but again, if you look at what's going on in there, if you're familiar with SQL Alchemy, it's a relatively simple query. You're not having to worry about the web framework. It's like, okay, I need a session, I need a request, and I need the bits and pieces, the text and offset in a minute. And the final one, final two is update. Again, this looks very familiar to the Git one, so I'm going to skip through because I'm just seeing the timer ticking away. Sorry for that. Delete, again, we have just an ID coming in. If it's there, we delete it, and I think we should be returning a 200, there's no content, 204, 205. If it isn't there, we just return a 404 instead anyway. So authentication, I want to talk about simply as saying, if you need to do authentication, FastAPI has really good support for a whole different set of authentication sources. However, the only one that's simple enough to explain and talk like this is just simple basic authentication. So how does that work? Well, we say we need a user. How do we implement our get current user? Well, we say we need some headers. We get some stuff out of the headers. Once we've parsed it, this is possibly the least secure authentication stuff you've ever seen, right? Because actually all we're doing is just returning the username to put in. We're not checking it's in a database. We're not checking the password. But it shows you the dependency injection flow, just saying, okay, inside get current user, we could also depend on a database session and go and check it in a database and have a look. And I'm rushing because I wanted to show the testing side of things, because this really shows the dependency injection shine. So who here's used PyTest? Okay, so we all know about fixtures, hopefully. Cool. So to work with FastAPI on the testing side, we just have some fixtures that set it up for us. So in this case, we're putting in a testing configuration using that configurator object we saw before. And we're setting up a test client, which works a lot like test clients in most other frameworks, where you can just issue requests. But it's set everything up for us. It's fired that setup handler. It's fired the event that set up the database connection. So we need one more fixture, which is actually to set the database for us. This is going through and creating all the tables, getting everything ready. But also, more importantly, at the end, this is all done inside a transaction, so we just roll it back at the end. So we've not left any database mess lying around. And inside our test, we just want that DB session object, right? So where does that come from? Well, that's our final fixture. That depends all the way up on the stuff we've seen before. And we configure our session with the database connection, and then we return one, so we actually get it set up nicely. And then this is our test. Lots of text, but basically quite simply, the test client we're posting in We're making some assertions about what's happened. Did we get the correct JSON back? Did the object actually make it into the database? Was there one of them and did it have the correct date? That should probably be expanded to check what attributes right, but the intention was there. So having rattled through all that and being seconds overdue, what's still left to do? So FastAPI is really unopinionated. What's left to do is perhaps abstract some of the code out that's shared between applications and put them in a library somewhere. Which, because of the way the dependency injection works, which I've hopefully managed to just about get across, is not actually a problem. It doesn't matter where the code is coming from, you just have to be able to import it and use it as a thing that one of your functions relies on. The OAuth stuff is quite wordy at the moment, so abstracting that out to library I think will benefit a lot. And support for context manager dependencies. So if you think of a dependency like a database connection, what you really often want is when the first time that dependency is asked for, you set up a session. The last time it's used, you then commit that transaction, so you don't have to think about that in your code again. That's something I think is still left to do. That was that weird middleware stuff that we had to kind of skip through quite quickly. I'm not sure I have any time for questions, but please come and grab me afterwards if you want to chat about this kind of stuff. These are the links here. The main one is just if you want to get the slides, they're up at the top. I will ping that into the talks channel as well so that you've got a link to it, but please feel free to come and ask me about any of this kind of stuff in the meantime. Cool, thank you very much.
Cool, thank you very much. Please head towards the assembly room for the lightning talks. Do you want to talk to Chris?